Question number 3. Point A and B are separated by a lake. To find the distance between them, a surveyor locates a point C on land such that the angle CAB is equal to 49.2 degrees. Find the distance between point A and point B. So I'm going to call that distance C because it's opposite to angle C. And clearly I am able to use the law of sines in this case because I have an angle and the opposite of that angle. However, I am not able to find distance C here unless I find angle C. And because I don't have any information to find angle C, I will be able to find angle B because I have the opposite of B, and then when we found B, we can find angle C. So I'm going to say sine B divided by 313, which is distance between CA, or the side B, equals sine 49.2 over 508, which is opposite to angle A. I'm going to multiply both sides by 313. These will cancel. I will have sine B is equal to sine 49.2 degrees times 313 divided by 508. I'm going to plug that into my calculator, so I will have sine B is equal to, rounded to 4 decimals, 0.4664. I rounded this to 4 decimals, but I am not going to use this rounded answer to find B. I'm going to say B is going to be the inverse sine of the answer, and this is how I'm going to enter it. So I'm going to say inverse sine of the answer on my calculator, and I will get B equals approximately 27.81 degrees. Now I found angle B. Angle C is going to be 180 degrees minus 27.81 minus 49.2. So I'm going to say 180 degrees minus my answer, minus 49.2. And I will get C is equal to approximately 102.98. I'm going to say 998. I rounded here to 4 decimal places. Now we need to find side C, so I'm going to say C divided by sine angle C, 102.9981, is equal to 508 divided by sine 49.2. I will multiply both sides by sine C. And I will get C is approximately equal to 653.8799 meters. So the distance C is equal to 653.88 meters, approximately rounded to 2 decimal places. Question number 4. Question number 4. A pilot is flying over a straight highway. He determines the angle of depression to 2 mile posts, 7 miles apart, to be 31 and 50 degrees, as shown in the figure. Find the distance of the plane from point A. So first we need to find this distance right here. Let me actually highlight that instead. And then we need to find the altitude of the airplane, which is basically the vertical distance from the airplane to the highway. So what we have here, so if I call the first line here L1 and the second line L2, notice how L1 is parallel to L2, and I have this line here is a transversal, which means it's going to produce 2 alternate equal angles. This angle is going to be equal to that angle. So this angle is going to be 31 degrees. This is basic geometry. And then if you look at the other transversal, which is this one right here, it's going to create two alternate equal angles, namely 50, and this angle is going to be 50 degrees as well. Now that we have two angles in that triangle, we can figure out the third angle. We can figure out this last angle right here. So we're going to say 180 degrees minus the 50 degrees minus 31 degrees, and we're going to get 99 degrees. So this angle is 99 degrees. Now we have all of the angles. We are able to determine the length from point A to the airplane. I'm going to name that side B because it's opposite to angle B here. And then I'm going to name the other side A. And then this side, I'm going to name it C. And I'm going to name this angle C right here. It's just for ease of use of terms. So now I can say that B over sine the opposite of B, which is 50 degrees, is equal to C, which is 7, over sine of 99 degrees. I'm going to multiply both sides by sine 50. These will cancel. B will be equal to 7 times sine 50 over sine 99 degrees. Make sure your calculator is in degree mode, and then plug these values. The answer is going to be approximately 5 miles and 5.43 miles. Now we found that distance. The other question is asking about, so the first answer is given. I'm going to highlight it. Now the other answer is to find the altitude of the airplane, which is basically the vertical distance from the airplane to the highway. In order to find that distance, we can basically use this right triangle. Let me highlight that right triangle. So this right triangle. We found the hypotenuse, and we need to find the opposite, and we can use the angle 31 degrees. So in relation to the angle 31 degrees and the hypotenuse, the altitude is the opposite, so we're going to use sine 31. So sine 31 degrees is equal to the hypotenuse, I'm going to name it h, divided by the opposite, which is the altitude. I'm going to say this is the height, divided by the hypotenuse length, which is 5.43. So I'm going to multiply both sides by 5.43. These will cancel, and the altitude, which is the height of the airplane, will be equal to 5.43 times sine 31 degrees. I'm going to plug that into my calculator. The height is approximately equal to 2.797 miles. And that is answer number 2. Question number 5. I have a triangle and I need to find side X. What I have to here, I have 2 sides and an angle. Basically, I have side, angle, side. In this case, I'm not able to use the law of sines because the law of sines require an angle and the opposite side of that angle to be given, or at least 2 angles and a side given. In this case, I can use the law of cosine to figure out x. So I'm going to say x squared is equal to 21 squared plus 21 squared minus 2 times 21 cosine the angle trapped in between them. Now, because these sides are equal, I can find it differently because I can use just simple geometry to figure out the angles. And then I can use the law of sines to figure this out. But I'm going to stick to this approach for now because it's more broad. So I have now x squared is equal to 882 minus 882 cosine 46 degrees. Now I'm going to find x squared is equal to 269.31, but I need x, which is the square root of the answer. So x is going to be approximately 16.41. So that is the answer for that question. And it says round to 4 decimals, so let me actually round to 4 decimals. There. So this is the answer for question number 5. Question number 6.